The third day of section 2 is a little bit trickier than the others. They're going to look like actual division problems, but they aren't because you're going to be stuck with either a fraction under the radical or a radical under a fraction. And in order to get rid of that, you have to rationalize. Rationalizing these quotients looks like multiplying the top and bottom by the same thing. So if you take a look at number 1, you can't divide and get a quotient for that. So you need to multiply top and bottom by something, some square root, to get rid of the bottom. Because these are square roots, I'm looking for groups of 2, and I only have 1 2 on the bottom, so I'm going to give it one more. What I give to the bottom must be given to the top. So the bottom ends up becoming the square root of 2 times the square root of 2, which is the square root of 4. And on the top, 1 times the square root of 2 is the square root of 2. On the bottom, though, the square root of 4 is just 2. On the top, you can't simplify the square root of 2, so that ends up being your final answer. Just be careful not to reduce or divide what's under the radical, because that 2 that's under the radical can't be reduced with the 2 on the bottom because one has a root and the other one doesn't. In number 2, you can't fix that by dividing either, so we're going to have to multiply top and bottom by the square root of something. Because it's a square root, I'm looking for groups of 2. I have 1x, so I'd like to give it one more. What I give to the bottom needs to be given to the top. The bottom becomes the square root of x times the square root of x, which is the square root of x squared. And on the top, 3 times root x is 3 root x. Be careful to keep the 3 on the outside and the x on the inside. The square root of x squared is just x. And on the top, I can't fix the square root of x. Just keep in mind I did start even and end odd on the bottom, so you do need absolute values. In number 3, I'm going to start by rewriting this as 2 separate square roots. It makes it a little bit easier when rationalizing. This is a square root, so I need 2 of everything. I have 1, 2, so I'd like one more. I have 1x, so I'd like one more of that as well. On the bottom, the square root of 2x times the square root of 2x is the square root of 4x squared. I'll see this one all the way out. The square root of 4 is 2, and the square root of x squared is x. On the top, the square root of 3 times the square root of 2x is the square root of 6x. 6 isn't a perfect square and can't be written as the product of one and another, so it just stays as the square root of 6x. You did start even and end odd, so you need absolute values around the x. Number 4 is a little different. We're switching to cube roots, which means you need 3 of everything. Multiply top and bottom by the cubed root. If you look at the bottom, I have 1x, which means I need 2 more. That's x squared. So the bottom becomes the cubed root of x cubed, because the cubed root of x times the cubed root of x squared is the cubed root of x cubed. On the top, the cubed root of 2 times the cubed root of x squared is the cubed root of 2x squared. So if you simplify the bottom, the cubed root of x squared is just x. And on the top, 2 is not a perfect cube, nor can it be rewritten as anything. And the x squared doesn't have enough to offer you to be able to simplify either. So it just stays the cubed root of 2x squared. No absolute values are necessary because you started odd. In number 5, I'm going to multiply top and bottom by the 4th root, because this is a 4th root. I need 4 of everything. I have 1 5, which means I would need 3 more. And 3 more 5s is 5 times 5 times 5, which is 125. I have 2 x's and I want 4 total, so I'll need 2 more. If I multiply the bottom, the 4th root of 5x squared times the 4th root of 125x squared is the 4th root of 625x to the 4th. 5 times 125 is 625, and x squared times x squared is x to the 4th. On the top, if I multiply those 4th roots, 2 times 125 is 250, and x times x squared is x cubed. So if I simplify the bottom, the 4th root of 625 is 5, and the fourth root of x to the fourth is x. At this step, if you've simplified the bottom and you have a radical, then you didn't multiply by the correct square, cubed, or fourth root. On the top, 250 is not a perfect fourth root, and it cannot, oh, maybe it can. So it just stays as the fourth root. Shouldn't be purple. Well, sorry. The fourth root of 250 x cubed. You did start even and end odd on the bottom, so you need absolute values around the x. All right, number 6. You have a couple of different options in this one. I'm actually going to play a different trick here. If you take a look, the y and y will cancel right from the very beginning. And if I reduce the x squared over x to the fifth, I get an x cubed in the bottom. And so this is the same as the cubed root of 3 on the top and the cubed root of 4x cubed on the bottom, because I canceled the y's and reduced the x's. And that makes it considerably easier. So what I really have is the cubed root of 3 on the top and the cubed root of 4x cubed on the bottom. So I need to multiply top and bottom by the cubed root of something. I have 1 4, and I'd really like 3, so I need 2 more. 2 more 4s is 4 times 4, which is 16. And the x cubed already has a group of 3, so I don't need any more of those. On the bottom, when I multiply, I get the cubed root of 48x cubed. Nope, just kidding. 4 times 16 is 64. On the top is where I'm getting my 48. The cubed root of 3 times the cubed root of 16 is 48. So on the bottom, you can cube root those, which is why we picked those numbers. The cubed root of 64 is 4, and the cubed root of x cubed is x. On the top, even though 48 isn't a perfect cube, it can be written as the product of 2 of them. So I'm going to change this as the cubed root of 8 times 6. And to go a little bit further on this one, the cubed root of 8 is 2, which leaves me with the cubed root of 6 behind it. And on the bottom, I still have a 4x. If you look, the 2 and the 4 can reduce. 2 and 4 reduce to 1 over 2. So what I really have is a 1 times the cubed root of 6 over 2x. Just for the sake of not wanting the 1 there, I am going to erase it, but putting it there isn't wrong. Absolute values are not necessary because I started odd.